All right, in this lesson, I want to talk about section 9.2. We're going to talk about solving quadratic equations by graphing. Before we solve quadratic equations by graphing, I want to show you very quickly why this works. So let's start with an equation like this. 2x minus 4 equals 0. All right, I want to solve this equation. Now, one way to do it would be to solve it algebraically, right? I could move the 4 to the other side and then divide by 2. Be solving it using algebra. Another way to do this, though, would be to graph the left-hand side, 2x minus 4. So we graph this piece right here. And then we also graph y equals 0, which is just the x-axis, and figure out where those two lines cross. So it will look something like this. This is not a great graph, but it doesn't have to be. So let's graph y equals 0. Well, y equals 0 is just the x-axis. Okay, so we'll solve. So we graph that piece. Then we graph the other side, 2x minus 4. That has a y-intercept of -4 and a slope of 2. So we'll go up 2 over 1. We'll go up 2 and over 1. And we find where these two lines cross. So there's our left-hand side. There's our right-hand side. And we see that they cross here at x equals 2. All right. Now, if you plug 2 in to x, you get 2 times 2, which is 4. 4 minus 4 is 0. In other words, you get a true statement. You get 0 equals 0. Okay, so that tells us that 2 is the solution to this equation. And this method of graphing, getting everything to one side and graphing it and find where it crosses the x-axis is how we're going to, one method we'll use for solving quadratic equations. Okay, for parabolas, they're a little bit more complicated than lines. And so we can see that there are 3 possible cases. All right, so case 1 is we have one solution. Oh, sorry, two solutions. 2 solutions. In other words, 2 places where the parabola crosses the x-axis, kind of like example 1 here. Case number 2, there's one solution. Okay, that would be an example like number 2 here, where the graph comes down and hits the x-axis at just one point. Case number 3, third case, is that there's no solution. That's a situation like example 3 down here, where the parabola never crosses the x-axis. Okay, so if we are trying to, a little bit more vocabulary here, sorry, before I get too far. We're going to use these words sort of interchangeably. So sometimes we will call the solutions, the x-intercepts. So here's, well, let me just list them all out here. So solutions, roots, zeros, and x-intercepts mean the same thing. Okay, so in general, you're looking for the x-intercepts. Now, these don't mean exactly the same thing. As you go on in mathematics, once you get to algebra 2, and if you go on to pre-calc, then you'll will be a little bit more careful with the vocabulary here. But for our purposes now, solutions, roots, zeros, and x-intercepts all mean basically the same thing. So I'm going to look at this graph over here. I'm going to notice that if I'm trying to solve this equation, right, so I want to know what are the x values that make this a true statement. I want to solve this equation. I can't just do this algebraically, right? I can't move the -3 over. I can't solve it with my typical algebra tools. So I graph the left, this, and then I find out where it crosses the x-axis. I get this graph and I see it crosses at -3 and -1. So our solutions are x equals -3 and -1. We just list those out. That's it. If you plug in 3 for x, -3, excuse me, you'll get 0 equals 0 once you simplify. Same thing with -1. This is an example of case number 1. Okay, you don't need to write that down when you're doing your assignments or whatever, but I just wanted to highlight it here that that's an example of the first case. Next, if we move over to here, we're looking again to solve this equation. when is this equation equal to 0 for what x values? And it's just at 3. So x equals 3. We just look at the graph. Where does it cross the x-axis? It's at 3. Moving down here. When is x squared plus 1 equal to 0? So in this one, I see that from the graph that it never crosses the x-axis. So this one has no solution. This would be case number 3. Case 3. All right. No solution. Never crosses the x-axis. Over here, you should try this one on your own. See if you can solve it. Again, you're looking for the x-intercepts, so pause. All right, here's the answer. Again, this is one like number 1. It has 2 x-intercepts, so your solutions are x equals -3 and -2. This is an example of case 1 where there's 2 solutions. Okay, so let's move on from the basic solving by graphing, and let's go down to a word problem here. So we're going to interpret this graph. A goalie kicks a ball. The graph of the ball's height is shown at the right. So over here, we have the graph of the ball's height. And we want to know, what is the ball's maximum height? So we look at the graph, and it's a little bit difficult to see, but right here at the top is 4.5. So we got 1, 2, 3, 4, 4.5. All right, so we can see that if this is height on the y-axis, then the highest point of the ball is at 4.5 feet. And I'm going to write this down here. The max height is the y value of the vertex. Okay? And then how long is the ball in the air? Well, on the y-axis, we have height. On the x-axis, we have time. Okay, so if we want to know how long the ball is in the air, we start at 0, time equals 0, that's when the ball is kicked, and we see, well, how long is it in the air? Well, it's in the air, 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 until it gets to here where the height is 0. That's the ground. So the question is, well, how long is it from here to here? In other words, you want to know what the x-axis is. This is at x equals 1. So if we have time in seconds on the x-axis, then we can write the ball's in the air for 1 second because it crosses at x equals 1, right? So again, you want to find where it hits the ground. We should write this down, I suppose. The ground sorry, it's written poorly. The ground is the x-axis in story problems. And I think that pretty much wraps up section 9.2. So again, you're just graphing, you're looking for x-intercepts to solve, and then we're mixing in a few word problems.